We now move to the next talk by Professor Anura Kurpad, who is India Alliance Margdarshi Fellow at St. John's Medical College, Bangalore. He's public health nutrition expert. He's going to talk to us about his research and his journey so far.
Yeah. Good afternoon, and thank you all for being here to listen to me, and congratulations on a very successful 10 years to the India Alliance. I'm from St. John's Medical College, and as a student, I remember St. John's was being built, and we used to see these long rows of laborers carrying loads on their head, and marvel at the way they managed to work on almost no food. And it really led to a series of questions about adaptation and the types of diet one eats. And as it progressed, I have become very interested in protein, and I've realized that for every question one asks and begins to answer, thinking, well, you've got the answer and it's going to change policy, you realize you've barely scratched the surface, and there are 10 more questions that need to be answered. So I'll take you through that, about positioning human nutrition at the crossroads. I do some work in many different nutrients, but you'll find protein is a theme that runs through what I'm talking about. And in India, policy and the feeling of charity and subsidy all come together and converge on cereals. And if you look at pictures of charitable activities or subsidy-based activities or disasters where food is being handed out, you will see large plates of cereals being handed out with almost nothing else. And that came from misunderstanding of nutrient requirements, which I will talk to you in a while. So the drivers of food policy in India as they stand today are based on a history of famine and an almost a feeling of embarrassment that we had to import food. And there was a great determination that we would be self-sufficient. And of course, the Green Revolution came along, and at the time, there was a misunderstanding about how much protein one required, and amino acids particularly. And as a result, it was because cereals don't have the best amino acid profiles, but they have protein. It just led to a great deal of enthusiasm for cereals. And of course, at the time, the dwarf wheat variety then was found in Mexico, and then it was brought into India. And there was a technocrat called M.S. Swaminathan who took it forward along with a great minister called Subramaniam. So I think there was a constellation of events that happened to push a lot of cereal production. And the government also then gave farmers so much assistance in terms of irrigation. And very importantly, and as I will tell you the economics of all this, is that they also told the farmers, we will buy whatever you produce. And that's a great incentive. But in the last few years, as I call it the post-Gates world, there has been a great deal of headlines around what is called hidden hunger. And that is not just the overt hunger that you see, that you can see and diagnose. There is a hidden hunger of micronutrient deficiencies, and that led to a lot of technological approaches to put chemicals into foods, particularly into poor quality foods. So cereals, again, you would put these chemicals in, and this is called fortification. And this has become a nostrum, really, for all maladies. It's almost like the government can say, yes, we are fortifying food, and then step away from the problem because it's like problem solved. It's actually not. It has distracted everyone, I think, from the development of an effective food system which seeks to give appropriate quality foods to otherwise poor people. And it has really pushed us to produce empty calories. And this is, I think I've shown this before, but for those of you who haven't seen it, this picture is of India's food production over the last 50, 60 years. And you'll see that there's one crop, food crop, that has been spectacular in its growth. Really, India is only second only to Brazil in producing this so-called food. And I put query marks there because I just wanted to see if any of you could guess what food that was. It is sugarcane. it is pretty much useless food. And what you'll see that there's another blue line just below that here, if you can, yeah, and that is the cereal production. What has become a flat line at the bottom is your production of protein-rich foods like pulses. And the reason, again, for this is policies that were based on, I think, the understanding in these middle years, in the 1980s and 70s, in these years, of what foods were really important, and an understanding now of what foods are important. And it's very hard to change systems that's been set in place. But effectively, you may ask, why is sugarcane such a big success? It's a success because you can get almost 100 tons of sugarcane off 1 acre. So if I were to dish out 1 acre of land to all of you and said, go out and make some money, you'd probably go out and do sugarcane. And the point is that it is also a very powerful system, what we call a cooperative. Sugarcane farmers get together in what's called a cooperative and set up a sugar mill, which then buys it. So the key is procurement. Take your stuff, someone has to buy it from you. And then, of course, these become very powerful cooperatives, and politicians tend to sit on the chair, on the head of all these things. And this kind of a toxic collaboration eventually leads to the biggest success of cooperatives. Having said that, if the government put its mind to it, like it did with the Green Revolution, it can, of course, push the production of highly productive types of cereals, as it did with the dwarf wheat variety. And of course, there's a great deal of subsidy that went into it, a great deal of sucking of water out of the ground with irrigation, and of course, extension work where farmers were helped along the way all the time. Well, milk has now become another very important thing that is growing, again, accompanied by a great sucking sound of milk being sucked out of the villages where it should be actually drunk and taken to the cities, where the milk cooperative dairies actually take that milk and do nice things to it, like the ice cream you ate. And it is really not, it is not consumed by the people who need it the most. So when you look at these graphs and you see things going upwards, remember, this is probably going to reach the top 5% of the population, or the 10%. The 75% who really need it are unlikely to see a great deal of that bounty. All right. Oh, I just wanted to show you this slide because it's really, you always ask the question, what drives farmers to do what they do? I'm going to invert a saying and say, to sow what they reap. And you'll see that here's sugarcane right in the middle. It's 71 to 100 tons per acre. And you'll find that you make quite a lot of money out of it at the last column there. And the input costs are high, but if you had the money, in other words, if I gave all of you 1 acre each, but the difference was some of you were rich, some of you were poor, it'll determine what you did with that 1 acre. Now, if you have some money, you'll sow sugarcane, and if you have some pals who'll buy it from you, you'll do sugarcane. All right, but if you didn't have any pals, you were very poor, the lowest input cost is this one, which is for millets, and that's why you'll find most subsistence farmers grow millets because it costs them the least to grow. So eventually, you'll find that most farmers will grow cereals because the government will come and take it off your hands. This is so important. It is most frustrating for a farmer to grow food and then have to throw it by the wayside because some middleman will just not take it. The government has stepped in to some extent and has redressed this equation. So the new set of figures I show there is the new minimum support price that the government has set. And you'll see that they have made it much more healthy for millets and for pulses, but eventually you'll still see that it's good for you to grow rice and wheat. And this is the puzzle that gets me all the time, because one of the things that I have to work with is, as much as I may, and I'm going to talk to you about how we did some research to change policy, and I was very happy about that, and now very, very, well, I'm not sad, but I just feel that maybe I shouldn't be so happy. But the thing is that there are very strange mechanisms that set into place with the procurement of food. There is an organization called the WTO, and the WTO objects strenuously to India procuring food from farmers. They consider this to be a subsidy for outputs. And an output subsidy is a no-no for the WTO. They call it an amber box violation, whereas if you were to give input subsidies, that is before the crop is grown, that is a green box thing. So India is always in trouble about this, and India, I'll talk you through what the problems are. Right now, what it looks like, because of our policies, it looks like we produce enough cereals for everybody at the rate of almost 400 grams per day. That's a lot of cereals. We are producing more vegetables, mainly tubers and roots. Again, think of that farmer. He needs someone to pick it up off him. He can't grow things that are very perishable, nothing like roots and tubers. And potatoes, onions, these are all the things that they grow. Milk is, of course, going on. Who gets it is another question. Look at where pulses has dropped. And now, with this background, I also want to tell you that really I'm pushing as much as we can to try and tell the government that, fortification is almost, there's a perversity in it that really makes you think you've done your job. But the job is to diversify the foods that are given to people. And what we need to give people is high quality foods with protein, such as pulses. We need to give them millets that contain iron, calcium, and fiber, animal source foods like milk, eggs, and meats, and of course, fruits and vegetables. And of course, none of this is given. If you think about the charitable subsidy system of India, a public distribution system of India, none of this. No oil neither. And this is what's happening. And if I say millets are good, well, look at what's happening here. Millets, the top two are the wheat and rice. Millets are just going downwards. And of course, when I go and look at what farming is being done, subsistence farmers are changing from millets to corn. Why would they grow corn or maize? Well, because the poultry farmers love it. So it's a much better cash crop for them. So you find that their own food is being changed for something else. There are very deep and difficult things to understand in this. The same thing exists for fruits and vegetables. I've spoken about this. So the demand and supply of pulses is right now, we produce about 17 million tons per year. That's a brown box. And according to the NSSO, we consume 12 tons. But India actually imports an additional 4 tons. So we have about 20 to 21 million tons. It's not clear where it all goes, but all of it does not go into homes. It goes into commercial production of different products as well. And my point is that I think the government should be giving a certain amount of pulses in the public distribution system. It should be putting more pulses into the ICDS. And if it did all these things, I think the government would have to make sure it had 22 million tons of pulses at its disposal to give to people. Now, if the government went out and started procuring pulses, trust me, you would have the WTO down on your neck very, very quickly, because it would be a violation, because they will not allow us to procure pulses for sure. Right now, we're fighting for our lives with cereals, because that itself is an orange box problem, and we've won what's called a peace clause right now, and it's just a mess. If we add pulses to this, it'll become an orange box violation. So to understand these things, we had some money from the Tata Trust, which actually put in money to support the National Institute of Nutrition. And what we did was to help them along this path. And we created a dashboard for people to understand where was food being produced. It's all a dashboard that's now gone live. Where was it being consumed? What nutrients are being consumed, and what are the health outcomes associated. And we have statisticians trying to work on triangulating these data sets, because India doesn't have a single data set that spans all these things. You have to start taking different ones, but they're very large data sets, and they're time series. So it's become a tremendous amount of data that we have now, that is now the NIN, the National Institute of Nutrition, is the custodian of. But the important part of that data that doesn't exist is the distribution networks. And I'll tell you, you may ask me, why am I doing all this? I'll tell you, because I'm now going to step back into the biology of what started me out on this path. And I've really come all this way. So there'll be a bit of a flashback coming your way. So the problem is farmers can give their produce to government. WTO doesn't like it. It can give it to middlemen who love it, and then they fix the prices. And farmers really get nothing out of it. And you've seen how, onions, the price varies, and you just don't know why. And then it goes to retailers. So we're tracking all this now, and that will also be going to the dashboard. So we want to locate human nutrition at the center of all this mess. And the important is supply should be driven by demand. And I'm going to talk about protein because this is one of the nutrients that I worked really hard on. And step back to when I was saying, what are the protein requirements? So the first thing we did, and I started this in about 1995, and my lab worked very hard on this, and that at the time, protein requirements were defined by a nitrogen balance. What people did was they just fed increasing amounts of an amino acid, measured the nitrogen balance, and found at which point the balance became a neutral balance was the requirement point. Nitrogen balance is really difficult to measure. I mean, if any of you have tried to measure it, getting a person to urinate for 24 hours into a single place is difficult. Urine disappears. So we really struggled with this till then. I learned some biochemistry and then figured that along with a collaborator that we could actually do amino acid balance, or what we call the carbon balance method. So I used to be at MIT and I came back to St. John's, and we worked out at St. John's that we could figure out this equilibrium of nitrogen, not through that messy nitrogen balance technique, but by using stable isotopes of amino acids, with stable isotope labeled amino acids, and then measure the oxidation through the oxidation and trapping of that label in the breath, in 13 carbon coming off the breath. And this we call the amino acid balance method, and we eventually went and did this for almost every amino acid, and a series of 15 papers that eventually resulted in being the primary data for the WHO to change the amino acid and protein requirements. So this was what I thought was mission accomplished. This is it. If WHO says this is what you need, perhaps governments will just fall in line. But it hasn't. In fact, I think it's taken 10 years, and I think it's still just beginning to impact policy. And what was the policy? What it did was, it was a paradigm shift that if the FAO and the WHO and the United Nations University in 1985 felt every food source gave you adequate protein, and that's on that left-hand column over there, everything greater than 100, whether you ate wheat, rice, millets, anything, you had enough protein. That's what drove the Green Revolution. But the new requirements actually now tell you there are only two sources of protein that you can eat and be sure that you're meeting all your essential amino acid requirements, and that's legumes and animal protein. So that was a big deal for us. And it was with a sense of wonder that I looked at the absolute lack of reaction to this. It just sank, and there was no reaction. But subsequently, we pushed a lot, and we got the FAO to take this up with a greater deal of enthusiasm. And the FAO then also began to ask us, well, you know that these are the sources of protein, but how sure are you they're digested? Because it looks like if you take an animal source protein, which has soft cell walls, it's likely that something that comes from a plant is not likely to be digested. And how do you measure digestion? Now that's intestinal function at its finest, because your problem is you can't measure digestion by simply taking a stool sample. You have to measure digestion by putting a big tube into the abdominal wall, puncturing the ileum, and then taking a sample of ileal output. It's what moves from the ileum to the colon is storage, and microbial action then begins, but there are no transporters for amino acids in the colonic mucosa. So whatever is generated by those bugs there can't be absorbed. So you really got to figure out what's happening up to the ileum, at the ileal level. And because I was working with isotopes, we came up with another way, which I thought was a very nice way, to measure digestion without putting holes into a person. And that was actually then discussed. The FAO, I got them to come down to Bangalore. They convened a meeting, and we all came up with a plan that was put out in an FAO report, which said, this is the way you should measure protein digestion. And we did that. What we did was effectively, if you can see on the left-hand side, there's a person with a colon. On the right-hand side, that unfortunate person has the colon removed. But what we were trying to do was to replicate that condition. And we did that by doing what we call the dual isotope method, where we intrinsically labeled all the proteins we were interested in and then fed them along with a reference amino acid mixture or something. So what I'm trying to tell you is you take a reference, which is 13 carbon labeled, and you take a deuterium labeled test protein, and they have a certain enrichment ratio of each amino acid. Say that ratio is 1. You feed it. It gets in, gets absorbed, gets digested, gets absorbed, and then gets hammered by the liver in first-pass metabolism. Now, but because you have a ratio, both the isotopic species of that amino acid would get hammered the same way by the liver and the splanchnic circulation. So effectively, you could then measure that ratio in the venous blood. And because it was a ratio, it nullified all the effects that would happen because of splanchnic uptake. So we actually created this system where we gave where we thought we'll create a deuterium labeled test protein and a 13C reference protein, or an amino acid mixture, as it could be whatever. Our biggest challenge was, how do we create these proteins, because they just weren't available. Collaboration. This is where I went to a friend at the University of Agricultural Sciences. On one of the trips, I think I was coming to meet Jitu anyway. I went and met this person at Crop Physiology, and he said it would be quite easy to grow in pots like that, and if I could give him heavy water, he could pulse water it such that, and we pulsed it at the time when it was flowering, so the seeds were just being formed. So we did that. We took the crop, and this fellowship, the Margdarshi fellowship, actually has been immensely helpful in this kind of this interdisciplinary work. And eventually we were able to grow all sorts of things: rice, ragi, chickpea, mung bean, you name it. And we did it all at this little site at the University of Agricultural Sciences. And that food could be fed. I have students who have fed it to adults. Initially that was the case, but now we feed it to less than 2-year-old infants, because our biggest question was, what is the food that will help growth in these less than 2-year-old infants? So that's where it is. And then we needed to look at animal source foods, so we got some chickens, laying chickens, and the biggest problem actually was to get our animal ethics committee to consider the chicken as an animal that could be kept in an animal house. For them, the rabbit was the biggest thing they could think of, so I had to demonstrate to them, well, a chicken's like a feathered rabbit. If that's it, then don't worry about it. And they agreed. So we were allowed to keep the chicken in our animal house, and that's the chicken. They actually loved, they grew used to our coming every day and squirting some labeled amino acids down their throats. We got some very nice labeled eggs. And of course, although I wanted to retire those chickens into a free-range heaven where they could live out the rest of the days, our ethics committee said, nothing doing, you will not do that, sacrifice them. Well, we sacrificed them, but then we had labeled meat. So we were able to also measure the digestibility of meat. And now I have a friendly goat, because I'm looking at milk. So we're growing these cowpea and maize, which is deuterium labeled. The goat is a large animal, and finding a place to keep a large animal with ethical approval is very difficult. But there's one place called the National Institute of Animal Physiology and Nutrition in Bangalore, which has happily kept my goat, and that's her. She's lactating. The unhappy person in that is the little, what's a baby goat called? A kid. And of course, the kid is now well fed with cow's milk. But her milk is being taken, then we take it to CFTRI in Mysore, where it is spray-dried, and then we get this innocuous-looking powder, which is labeled milk protein, and we're going to start our experiments on milk. That's our final set. But at the end of it, we've been creating a database for the FAO to use, and in fact, this was, I'm really happy with this headline, which was, it was a novel method. Just like the novel method to measure the requirements, now is a novel method to measure digestibility. And you'll see here the great disappointment the legume people have. Everyone loves pulses, but their digestibility on average is only about 60%. So what you thought you should eat, and you thought, I need so much of pulses for good health, well, you need perhaps double that. But if you look at spirulina, which is an algal protein or egg or meat, it's all pretty good. It's about 90%. I mean, I always tell people, look, don't see pulses, bad digestibility as a bad thing. It just means you should eat more. There's nothing wrong with that. And I often think that human beings have evolved to eat poor foods. We love it. I think our colons love it when you give them things to do. I mean, the ridiculous example is to kind of think, can I take more and more refined things and feed people? and you find you get unhealthy populations, you get fat populations, you get all sorts of colonically disturbed populations. But when we eat foods that we don't digest, the colon loves it, you're happy, well, a little gas maybe, but in general, you are a happy person. But now that we gave the FAO and we've given the WHO a fair idea of digestibility, we've actually looked at protein intakes now. And what we thought earlier, that there was no protein deficiency, there is some protein deficiency. And especially in areas like the Northeast, which you've never thought, the entire central highlands of India, and then coming down to the south. The belt where a lot of milk is drunk, you'll find has less risk of deficiency. And of course, there's a great deal of this interest around something that interferes with the ability to absorb food, and that's called environmental enteric dysfunction, an extremely frustrating condition to pin down, but I'm trying very hard to do that as well. So we've looked at the digestibility of common complementary foods as well, and one thing we have found when you actually take those data and put it into data sets that exist, like the National Nutrition Monitoring Bureau, you do find that the quality of food, the protein that's being eaten, does relate in some way to stunting. It's not the entire reason for it, but it does have some amount of relation to it. And the states that are like Kerala and others, which have high amounts of fish and milk, do much better than states like Orissa, where it's mainly cereal-based. Environmental dysfunction also is a problem, and we are looking at some indicators of that, particularly of the dendritic cell activation, where tryptophan is metabolized to kynurenine. And there's a whole host of different markers that we're looking at in these children or in school children. And we do find that that in itself relates to stunting to some extent, but it's hard to pin down the effect of that on digestibility. Nevertheless, oh yes, there's just one last bit, and that was because we had actually dehulled, we took mung bean. Mung bean has a digestibility of 60%, and we dehulled it. And when you dehull it, its digestibility goes up by 10%. So we thought, well, we got rid of anti-proteases, but also some polyphenols. And so we thought, well, if you're going to look at polyphenols, why not look at tea? And if you drink tea with your meals, one of the things it's going to do is destroy iron absorption. But the other thing it does is it does reduce digestibility of all your amino acids by about 15%, and it's consistent across all amino acids. So please don't drink tea with your meal. Drink it in between. And I'm now coming to the end of my thing, and that is, I've been going on and on about, so let me just head back a bit. So far you think I've been doing things. I've got the WHO, I've given them the primary data to change their requirements. That's good. Now the FAO is going to take what I'm producing and there's going to be something coming out on the digestibility. So we are beginning to see all this. But now let me take you back to the beginning of where I started all this. It was, yes, you know that you need to feed so much, but how on earth do you get it to people? It's really difficult, because if you expect the government to do it, then the government has to have a mechanism for procuring it, storing it, and so on. And we know that even food storage is very bad. A short story that I can tell you is that DST at one stage approached me to ask, do you think we should do some research, because we are having all these grains rotting in these heaps, and should we do some research to actually find, can we do something to reduce that rotting rate? And I just told them, well, yes, you can, and that is increase the amount of anti-proteases in it. So you can get a grain that will not rot, but you won't digest it either, because it's just, that's what anti-proteases are there for. They're there to reduce your rotting. Have I got about another 2 minutes? Yeah, okay. So that's my problem, that eventually all this work we have done it's academic. It's gone into these kind of documents of the FAO and the WHO. It's changed things. But eventually to change practice on the ground is one of the most difficult things I can think of. And that's why I've gone into trying to figure out the ways of procurement and the ways middlemen actually work, because that's important. But I have to tell you with a sinking heart that I think I'm failing in all this. And if I go to DBT and say, let's do some research on this. There's not that much enthusiasm for it. But if I say, let's do some research on finding out which genus of rice has the highest protein, there's a great deal of spark of excitement and, oh yes, let's do that. It's like cereals again. So it's almost like, okay, I'm giving up. I'm happy. Let's try and get some cereals that have high protein. And that's where we are right now. There's a lot of enthusiasm about trying to find a cereal that feels like a dal. It sounds odd, isn't it? A cereal, a rice, I mean, you look at it, there's a certain mouth chew that you like. The more protein you put into that grain, it's going to get gritty and you won't like it. But that's where the research interests are. I also want to tell you about the perversity of putting nutrients into food, chemicals into food. It works like all drugs do. It works in efficacy studies. It works when you actually do a little study of about 200 people, carefully controlled, check everything. But the moment you put it into the messy world of effectiveness and scaling up, as with any clinical treatment, what works in a trial is not necessarily that what works when you just prescribe it and you leave it to the patient to take it. It doesn't. And this is some data that I've just been doing. Remember I told you about that dashboard that I showed you of food intake and food production, blah, blah, blah. Well, we have triangulated those data sets, and then you can begin to look at the intake of iron versus the risk of anemia on the y-axis, and you'll see that you can go on increasing the amount of iron, you hardly touch the risk of anemia in real data. So I often ask, why do all this? Isn't it easier to just give some fruits? Because you can model the giving of fruits along with your food, and you'll find that that slope becomes much steeper. So that's, again, where I'm trying to look at positioning nutrition at the center of policy, but that's to do with iron. I just want to end here with one question to all of you. I'm giving you a rather negative view of the world, but there was one intervention on extremely stunted children. Look, very stunted. They've got a value of -3 for the height for age. That's really low. But they were given an intervention and they magically, over 2 years, almost became normal. We've never seen this. Any guesses what that intervention was? Yes? No? No. Well, you'll get some. I'm not saying you won't, but this is stunning, isn't it? -3 to almost 0 in 2 years. Same children, by the way, followed up. Well, here's the reason. It was adoption. These are children who were adopted as very, very malnourished kids and taken to Sweden. And there was a study that was published in Sweden I'm so sorry, it's very small, but it was published in the Uppsala Journal of Medical Sciences. And it's a cohort of children who were followed. And what's the point I'm trying to make? Not that adoption's the way we should sort our problems, but that I think it's a systemic issue. It's not like you're going to solve this problem by giving protein or giving iron or anything else. I think it's everything together. And that's why I always tell people that there is no magic bullet. People who tell you they have a magic bullet that's going to solve the world's problems are probably wrong, are wrong, definitely. I mean, there's no question that iron fortification has not solved the world's anemia problems. And if I say give protein to kids, give them an egg, give them some milk, yes, it will make it better, but overall, the grinding poverty that exists and the social problems are also very, very important. So I want to end by saying that while we want to position nutrition at the center of policy, I think, we have to understand it's a broader world, and we have to be more optimistic. Thank you.
Thank you very much, Anurag. The lovely data sets, the useful advice on food habits, and
Well,
also
not much advice, but more.
and the insights. Thank you very much. Can we take just two quick questions?
Thank you for a great talk. My name is Priyaranjan. I work with Amity University, and I jointly work with my friend Rajiv here. He's head of Amity Institute of Public Health. So, sir, I've been collecting actually data with Musahars in Bihar. This is a very, I should not use the word downtrodden, very poor community. And mostly earlier they used to live in villages where they will, clean up the fields after harvest. And whatever rats are there, they will smoke those rats and eat it up. That's why they're called mushar, means one who can, kill the mouse. And after that, I find that you say that 400 cereals per person possibly. That's an average calculation. What the food availability to them is actually very scarce.
Yes.
And these guys used to be in villages, very well built because they will do hard work. But in cities, they do rickshaw and all that stuff. Their situation is dismal. I mean, they're essentially on the verge of death or extinction, whatever you want to call it. So nutrition is not just how much we are producing. I think another perspective is that how much a person is able to procure that from market, village, harvest, or whatever it is. Because food availability is not proportional to our production. Our production can be very high, still people can be starving. So there is an economic gap here. And I think that possibly, we should look at from both supply and the perspective you gave from supply is great. But I think the demand side and availability to the person possibly will add some more things. Thank you.
Yeah, I can't agree with you more. What I've given you are national averages. I think the whole problem is at a state level. States decide what they want to do, and eventually a district collector can really decide what he wants to do, or he or she wants to do in these things. So it's a very heterogeneous situation. And I've been trying very hard now to use these findings in improving the take-home rations. And I find that every district does its own thing. And so there's no one-size-fits-all. We have to be very, very careful about that. So thank you for that. I'm glad you pointed out the heterogeneity of India. Yes?
Very nice work. Talking about policy, as you know, food labels have a conspicuous absence of recommended daily allowance for proteins. So people and societies are getting fixated on, they all have memorized the requirements, although they are for 2,000 calories for an average person. Most people are not average. For carbohydrates, for fats, but not for proteins. Can you comment on that? Because you're talking about influencing the system. And there are many people, I would argue, even middle-class people, especially vegetarians, who need to watch that. But they don't know what the number is that they should target. And if it's not there, then they are not going to do it.
Food labeling is a very difficult topic. It's something that I am involved in at a policy level, mainly for high-fat, sugar, and salt foods, HFSS foods. And I'll tell you, we have a draft policy in place, but there's so much pushback from industry that it's not yet been regularized. It's a draft policy, which means it's nothing yet. But I do want to say that, food labeling is one thing, but if you look at the behavior of millennials, who are the next generation, or the centennials, and this is studies that in Christmas, on Christmas, on the Christmas issue of BMG, there's a paper coming out in which I was a part of, which looked at global patterns of calories in foods, fast foods and restaurant foods. And I would like to ask you what you think a regular North Indian meal with paneer and parathas and some rice and raita and some vegetables, how many calories do you think that would have? Any guess? Wild guess? One meal in a restaurant. 1,300. So the actual portion size, the portion calories in India are huge. A masala dosa is about 1,100 calories. And this was actually measured because we went to the restaurant, took the whole thing, put it in a bag, brought it home, blenderized it, freeze-dried it, and then bomb calorimetric. So I mean, it was good work. And those restaurants are going to be unhappy with us, I'm sure. But the point I'm making is that also there's another policy that I'm very much involved with, which is setting the energy requirements of Indians. The policy right now is to feed people according to a heavy activity schedule of 2,200, 2,400 calories. And I've been measuring a lot of this. And I'll tell you, the adaptations to the way we work, or to mechanization, our energy expenditure has actually dropped. Many people are around here, probably you would be on, you'd need to eat about 1,500 to 1,800 calories, and that should do you. And here's your point. You go and eat one meal, as you probably did at the buffet, and think about it, you probably met your entire day's requirements. So I think you're absolutely right. It's not just the labeling of produced food, which are these biscuit packets and snacks. It's the labeling of restaurants' foods. I mean, you have to know what you're eating. It is huge. Yes. Sorry, I hope I've answered your question. It was vague, but that's the best I can do.
Thank you very much. I'm sorry we have to cut short the questions now because we're running behind schedule. Thank you very much, Professor Anura, again.